see what any of the D.
Alright, I'll be looking at the difference between elastic and inelastic collision. What you need to understand about collision is when two objects, when they hit up each other, that is collision. In elastic collision, after collision, the bodies, they move apart, they move with different velocities. While in inelastic collision, the two bodies move together after impact or after collision. Let us look at the expression for elastic and inelastic collision. Also, there are expressions in coefficient of restitution very fast. This is body m1 moving with a velocity of u1. This is body m2 moving with a velocity of u2. This is before collision. They are moving in the same direction. This is before collision. So if after collision they now move together, that is, they coalesce with the same velocity, you will say that this is inelastic collision. So this kind of collision is said to be inelastic. Now, what will you observe? You observe that body 1 is whose mass is m1 is moving in a positive x direction with an initial velocity u1, while that of body 2 with a mass whose mass is m2 is moving with an initial velocity u2. Then after collision, both of them are now moving together. By law of conservation of momentum, we say by law of principle, you can say law, by law of conservation of linear momentum. Momentum means the product of the product of mass and the velocity. So for this, you have sum of the momentum before collision to be sum of the momentum after collision. Here you have the momentum to be m1 times u1. Here is m2 times u2, that is before. And after, you're going to have m1 times v plus m2 times v. Because v is the same, you can now say it is m1 u1 plus m2 u2 to be equals to m1 plus m2 multiplied by v. This is the expression or the equation for the linear momentum in inelastic collision. So let's talk about the coefficient of restitution now. Having known let's talk about the coefficient of restitution. Anytime we talk about coefficient of restitution, it is referring to the ratio of the velocities, the final velocities to the initial velocities. You have E to be this over this, which means V2 minus V1 over U1 minus U2. For inelastic collision, E is equal to 0. That means that V2 minus V1 over U1 minus U2 equals 0. And we can say that V2 is equal to V1 and is equal to V. This V is called common velocity. You know velocity? Velocity is in meter per seconds. Alright. So we've been able to write the expression for the momentum and the expression for the coefficient of restitution. What about the energy in inelastic collision? The energy in inelastic collision. Don't forget that kinetic energy is half mv squared. Half mv squared. So we can refer to the kinetic energy before and the kinetic energy after. So what you're going to have will be you have half m1 u1 squared plus half m2 u2 squared to be equals to half m1 v squared plus half m2 v squared, because after the collision they are moving with the same velocities. Now we can bring this out and we call it loss of energy. So the loss of energy now will be equals to half m1 u1 squared plus half m2 u2 squared minus half v squared into m1 plus m2, because v squared is common there, so we can bring it out as loss in kinetic energy. And I want you to know something about inelastic collision. Something about inelastic collision is that the kinetic energy before is greater than the kinetic energy after. Is not equal to it. That is why we say that the kinetic energy is not conserved. Thank you.